thanks everybody for coming. We'll do our best to keep this on time. As the agenda and the announcements have said, we're going to focus this meeting on vocabularies and semantics for polar data. Before doing that, I'm just going to provide a very brief summary or overview of some of the activities at the recent Arctic Science Summit Week in Prague, and I would also invite anybody else who attended, if they want to add to that, feel free to do so. So in Prague, we had I can't remember what number it was, but the Arctic Science Summit Week. That was a combination of business meetings for the International Arctic Science Committee, and then a four-day conference. So the science meetings went very well. There were meetings across all of the various IASC working groups, which includes the cryosphere, human and social working group, terrestrial, and so on. And I attended a number of those meetings, a lot of good discussion about the science, but also data was a prevalent conversation throughout many of the meetings as well. The science meeting itself, the conference, was very well attended. I don't have an exact number, but it was definitely into the many hundreds. We had a session 13.1 that focused on data and systems thinking. So how do we sort of integrate data with broader systems thinking? That was well attended and had 10 talks. Shannon Christopherson Vossapol, who's on the line, was my co-chair on that. So we had, I believe it was 11 oral presentations and about 8 poster presentations as part of that session. And that ranged everything from looking at data collections within museums, right through to vocabularies and semantics. Suri Jodison also presented on that in the session, through to various types of data management systems and things like agent-based modeling from some colleagues actually from Russia who are doing some really interesting work on various types of modeling. So that was great, and I think there was just a general consensus that data is definitely an important topic within our community. The week was wrapped up with the SEAN board meeting, and I presented there on behalf of the Arctic Data Committee, and we had a lot of discussion there about also the role of data within a broader integrated Arctic observing system. So all in all, it was a really productive and excellent week. Saw a lot of familiar faces there and met some new people as well. And I will be seeing if the conference organizers are open to sharing the abstracts. I have some of the talks from the presenters, and I'll be working on making those available as well. If there's anybody else who attended who wanted to add anything, feel free to do so now. Remembering to unmute yourself. Okay, well, we'll leave it at that. If anyone changes their mind at some point, feel free to just drop a little text message into the chat window, and we can come back to that. So with that, I think we can move on in the agenda. So over the last, well, few decades, there's been a lot of discussion about the importance of vocabularies and semantics in relation to data sharing. This has come up in many meetings and conferences. It's a broad topic within the data management world, worldwide, and it's certainly something that comes up a lot when we're thinking about polar data. There were a number of presentations, as I said, at the recent Arctic Science Summit Week, at Polar Data Forums, the one that was held in Waterloo a couple of years back and the one in Tokyo a couple of years before that. It was definitely an important topic. In the context of various groups that are organized, there's been some discussion about organizing some sort of body or some sort of forum to have some of these discussions. And so this is going to be on the agenda for later in this meeting. But to start, what I wanted to do is put out some ideas and also get some people who are doing some work in this area to present on what they're doing, just so that people on the call have a good sense of some of the activities that are out there. And if you're on the line and you're not presenting, certainly we really encourage you to let us know what you're doing in your work or at your organization. So to start, I'm just going to go through some high-level sort of ideas around vocabularies and semantics. Some of the folks on the line may not be familiar with this, and others may be experts. So for those experts, please just bear with us through this. So I'll talk a bit about some general concepts and then just a few of the projects that I have a connection to, and then we'll lead into a couple of other speakers, to Ruth and Bryce. So Sarah, if you could go to the next slide, please.
Sorry, for some reason it's not advancing.
Maybe just try your arrow. There we go. Okay.
Yeah, just have to scroll. There we
Yeah.
go.
And so go maybe to the next slide as well. So interestingly enough, semantics can mean a whole lot of different things. In this meeting, the focus really is on semantics and vocabularies in relation to interoperability or data sharing. So we've had a number of sessions in this group, as well as across the community, on interoperability, and the idea of really trying to create this amazing distributed system where data can be readily shared across different nodes, and used for science, for policy, and all kinds of other uses. A lot of development has happened in this space, particularly over the last couple of decades, with all kinds of different interoperability standards out there. A few sort of example brands on the slide there. And there's much in the way of progress. One of the areas, though, there's still some work to be done, is in the area of semantics and vocabularies. And the challenge there, of course, is you can exchange data from one data center to another, perhaps, or one researcher to another. However, if there are elements in the data, whether those be types of observations and measurements, or whether they be things like keywords or classification systems, the terms related to classification systems, is if you don't understand what's being provided, you can't readily use the data together. Standardization is one approach to trying to solve this issue, and that's certainly something that some progress is being made on, and there's a lot of efforts in that area. But standardization is not always the solution if you're thinking about highly interdisciplinary work, or really complex environments or domains where standardization is a real challenge. Nevertheless, we want to make progress on it, so it's a pretty fundamental part of moving forward on interoperability. Next slide, please. So standardization and coming up with accepted or agreed upon vocabularies, or sometimes what we call controlled vocabularies, where they're actually very strict sort of rules and regulations on how the vocabulary is developed. It's certainly not new. There are many out there. Just a couple of examples on here, where we have the WMO sea ice nomenclature that's been published. US Permafrost Association has a glossary, and many other domains have glossaries and nomenclatures. Next slide, please. What we're starting to see now is a movement towards moving these nomenclatures and these vocabularies to web-based services, or data as a service, software as a service. So here's one example, which is the NERC, or NERC vocabulary server, out of the United Kingdom. So that's the British Oceanographic Data Center, has been hosting this for a number of years for the oceans community. So this allows individuals or machine-to-machine sort of communication, and the machine-to-machine is the ultimate goal here, so that you can readily share and access the vocabularies in a very efficient way. Next slide, please. One of the sort of killer apps, or the ideal goals here, is to be able to use these types of system to connect, system to system, and even across knowledge domains. So here's just an example of how you might connect indigenous knowledge, in this case Inuktitut, in the Inuktitut language, to WMO terminology, for example. So the potential is there. There's work being done in this area, but certainly quite a bit left to do. Next slide. There are a number of models. I'm not going to go into the details, but generally under this idea of semantics, or the semantic web, which is looking at different ways now, or ways of modeling vocabularies, such that we would use a graph. And the graph idea is that you would have a concept with a relationship to another concept. And this can be used to create very complex, simple or very complex knowledge models, and try and model the terminology, as well as the relationships between terminology and the concepts that the terminology relates to. Next slide. So that sort of very simple model can be used within software and standards paradigms under the semantic web model to create complex ontologies, as we call them. Here's a screen share from the sea ice ontologies. I'll give you a web link there to these in a moment, but they were done under the Semantic Sea Ice Interoperability Initiative that first Mark Parsons led, and then Ruth Duerr did most of the leadership of that project. Siri Jota Singh Khalsa, who's on the line, was also part of that project, and I was a member as well. So this uses this sort of triple approach, or this sort of graph approach, to try to model out the semantics of sea ice. Next slide, please. And in addition to being able to create, you know, relationships and the relationships between concepts, you can also add a lot of semantic information, such as just a basic definition that you might have in a typical glossary. So on the lower right part of the screen, you see that here, where there's a definition. But the definition in this case actually has quantitative aspects. So it talks about the definition being a component of the concentration of sea ice with a numerical value. So the text that you see on the upper right here in the corner there relates to that, to the definition being actually related to those numeric values. So all kinds of very complex information can be modeled and encoded within one of these ontologies. Next slide. That's just a link there, a reference there to the project that created the sea ice ontology. So that's the first of the projects I'm sort of putting out there as an example of some work being done. That web page that I'm showing is being worked on right now. So I haven't provided the URL, but the actual ontologies at the moment are on GitHub. You see the link there. And Ruth and I and others we're working on where those will be hosted over the long term. So we're looking at a long-term sort of publication space for that. Next slide, please. Another project that is going on is called Permadata. So this is an NSF funded project that's looking at making more permafrost data available. And it has a number of different goals. And one of them is actually looking at semantic infrastructure for standard variable naming and creation of an ontology. Next slide, please. So I'm working on that with a team of permafrost scientists and others. Colleen Strawhacker, who's on the line, is another investigator on that. It's led by Kevin Schaefer at NSIDC. And so what we're doing at the moment is developing what we call, I'll call it a proto-ontology for now. It's not meant to be authoritative. So we're looking at different ways of doing that. We've been working with Ruth on some of the natural language processing approaches that she's been experimenting on, and she'll talk a little bit about that, and then also looking at various glossaries, etc. So that's an ongoing project that'll be happening over the next couple of years, I think we have left on that one. Next slide. Some other work that's being done, and this was part of the Sea Ice Interoperability Initiative, as well as in partnership with Aloka and a number of community partners. So there we're looking at the possible connections, cross-cultural connections. So looking at indigenous knowledge and terminology, specifically in relation to sea ice, and then looking at how we might link that to science and operational. So that's one of the other projects that we're working on. Next slide, please. So just to sort of wrap up my talk, we're actually in conversations now. There is a group called the Arctic Data Committee. Some of you online are members of that committee, and others may not know about it. It's an international committee that was formed just over 2 years ago, and we're really looking at data from a sort of a pan-Arctic international perspective. And there are a number of different activities that ADC, as it's known, is involved in. And one of them is related to standards and interoperability. So at a couple of our meetings now, we've talked about the importance of semantics and vocabularies. And now, after some discussion at the meetings in Prague, I think we're ready to start moving forward with a focus group of some type. And Øystein Godoy, who's with METNO in Norway, and also represents WMO and some other groups, has taken an interest in leading that. Or has offered to provide some leadership there, and certainly would welcome any help that he can get. And the idea there as well is not to do that within a silo, but to think about relationships to other groups, such as the Research Data Alliance, RDA, which is doing a lot of good work in this area, as well as the ESIP, or the Earth Sciences Information Professionals, Federation of Earth Science Information Professionals. So we'll come back to that at the end of our presentations, but that sort of gives you some context on vocabularies and semantics in general, and then some of the projects that are going on. And with that, I will hand it off to Ruth. What I might ask is maybe if we could just hold questions until Ruth and Bryce have spoken, and then we can get into it, just our general sort of town hall approach and have open conversation.
Okay, I had to unmute twice. Can you hear me now?
We can.
Okay, great. All right, so my name is Ruth Duerr, and I titled this talk Polar Insights, which actually is the name of an NSF-funded project that I have that actually Suri Joda and I are both on. I'm not actually particularly going to talk directly about that particular project, but I note that that project will be using a lot of the outputs from some of the other projects that I am planning on talking about. So if you could go to the next slide, please. All right, so Peter started off talking about Psi, and he talked specifically about the conceptual mapping and graphs that came out of the Psi project. I'm going to take a slightly different tack about talking about that project, the Semantic Sea Ice Interoperability Initiative. And then I'll move on to the project Peter mentioned, which starts to deal with natural language processing and machine learning. And that would be the Clear Earth project. And then I actually want to diverge a little bit, because I thought it was important for this group to realize or to learn about some of the other communities who are working in this space and some of the activities that are happening there that might be useful for this community to tap into, and then end up with just a simple slide on some other geosemantic resources that exist that people might be interested in using. Next slide, please. Okay, so Peter talked about the Semantic Sea Ice Interoperability Initiative. These are the actual ontologies that were created as a part of those, and you see that they're based off various nomenclatures and documents. The interesting thing about that project, at least to me, I think there's probably many reasons why that project was interesting, is that it took the WMO Sea Ice nomenclature, which actually captures quite a bit of physics, if you want to call it that, about the meaning of terms related to sea ice in that vocabulary. And so you took something that was pretty much physics-based, and then through the boundary object of an egg code, went all the way to data. So what you actually could do is to go all the way from physics to connecting that to actual data measurements. And in that case, we actually experimented with creating open link data from the Canadian sea ice charts in Sigrid 3 format. And what that meant was then all of a sudden you could do very simple interfaces, which unfortunately I didn't capture a picture and put it on here, that would allow you to query, for example, ship track information from another data center, the Bico Demo data center, and overlay that with information about sea ice on that ship track. And so that, from an interoperability standpoint, was an interesting result. I note that the ontologies themselves, as Peter mentioned, are still in process. We're up to version 3 now. mostly because the original first two versions really only included the information from the CIS nomenclature that were actually captured on maps, and there's a lot more information in that vocabulary. And similarly, the semantics community has been developing over the time since those were started. And there is now a desire by the community to make the size of individual building blocks of ontologies much smaller. And so based on some recommendations from Pascal Hitzler's group, I've agreed to do that as part of version 3. And then lastly, because we're dealing with something that's versioning and changing over time, we actually have to include information to allow users of these vocabularies to understand which versions of terms, etc., they're using. So next slide, please. So one of the things I learned during this Semantic CIS Interoperability Initiative is that hand building ontologies is a pretty slow and painful process. And so I was hoping to actually speed that up. Now the medical and biological fields actually have become really quite advanced in these areas. They're typically considerably better funded in terms of resources, and so they've made a lot of progress in even doing things such as automatically generating semantic resources of various types. And so this project was all about trying to take some of the technologies and processes used over in those other disciplines and then applying them to earth science. This was funded out of NSF's DIBS program, but actually is kind of an aid to NSF's much larger EarthCube program. And so the fields that we were trying to do this reapplication are geology, cryospheric science, which covers basically everything, and then biology. And so what we were using is supervised machine learning to generate semantic resources. So what do I mean by supervised? On the right-hand side of your screen, you'll see basically a piece of text. It's actually a page out of the WMO CIS nomenclature that's been marked up. And one of the terms, the term fast ice, which right at the moment I'm not reading because it's a little small, is showing up on the extreme right-hand column, and you can see all of the various kinds of implications and relationships that Peter was talking about. For example, it's attached to the shore, or to an ice wall, or to an ice front, or between grounded icebergs, or between shoals. So you can capture and annotate that information, and then if you have enough of those kinds of annotations, then one can use that to train a machine to basically do similar things to other texts. And so this project's a 3-year project, and we're in year 2 of that. And the first outputs, aside from a large number of lessons learned, is a set of semantic resources that are basically glossaries that have been, where each term and its definition and its source are being turned into permalinks. In other words, something that could be used in an ontology and given a citation. I'll give an example on the next screen. And we've actually finally gotten to the stage where we have enough annotation so that we can actually do the first pass through the machine learning algorithms to generate ontologies. And we expect to show results of that at a meeting in June. And one thing I do note is that all these projects are connected together in that we are using the size sea ice ontologies to validate that the output of this process is actually working. You know, the first goal would be to see if the machine can get out of the WMO sea ice nomenclature the same ontologies that I got out. And then secondly, to see if just reading the more general literature, those same ontologies still pop out. So next screen. And so this is what I was saying about the YAMZ terminology. So each term has this permalink, which you can see down in the left, down in the right-hand corner for this design safe. I'm using these examples because I wanted to show how a term could be linked to a specific, in this case, they linked it to a specific project. In the case of my project, we're linking it to a specific source document. So next screen. Okay, so actually I should note that the Polar Insights project, which is also NSF funded, actually takes those results from those previous two projects and uses them then to start to actually look at the entire available polar literature to identify data and resources and insights, you know, what topics are becoming popular and that sort of thing. But I wanted to change topics a bit and talk about some of the other fairly major ontological things that have been happening in science. And one of those is that in the earth sciences, the ontology suite, which was originally developed by Rob Raskin at JPL, is one of the main ontologies that's in pretty broad use. It came out of, you know, JPL, so that's basically NASA, but it has had a lot of extensions in a lot of areas. It's a fairly, I guess I would call it a moderately high level ontology, but you can see by the different kinds of topics that it covers that there's a lot in there, and that it even includes cryospheric things under the realm, which is in orange. And it's taken several years for that ontology to become open sourced out of the government. And it's now been recently adopted by the Federation of Earth Science Information Partners, and who are trying to develop a governance process for it. In the meantime, I mentioned earlier that the biomedical, et cetera, communities have been working for many, many years on these sorts of semantic resources in their community. And Pierluigi Buttigieg actually has been working on something called the ENVO ontology, which is about the environment. And that's an extension from the more medically and genetically based ontologies that are often used in that field. But that field has a pretty well developed practice and repository for their semantic resources called the Obo Foundry, which, for example, has best practices in how to create ontologies, etc. And so there have been these two camps, I guess you could call them, the Geo camp with their sweet high-level ontology, and then the ontologies that have come out of the Obo Foundries, which are equivalently high-level, but then going to quite detailed in the genetic type areas. And this ENVO ontology actually is starting to bridge across those two realms. And so actually at this summer's upcoming ESIP meeting, there will be a session where the two groups kind of get together face to face and explore how to merge these two very different disciplines and start making the ontologies that exist in each realm play very nicely together. One thing I will note is that suite and actually any ontology that gets really into the detailed physics or other attributes of a specific discipline needs to have people who are really knowledgeable in that discipline to curate its various parts. And on the next screen, I'll give you an example of that, which is from the current version of Suite, which says that a lead, which is basically a crack or opening in the ice, is actually a kind of sea ice, where I would say that that's not very accurate. They have got Polynia more accurately described as being surrounded by sea ice, but lead at this point is not quite accurate. So with that, move on to the last slide. So actually there is a list of geoscience ontologies that have been created over the time, and you can, and it also describes, you know, their sources, and you can see that several of these have the word sweet in them. Others have the word dolce or some other such source. But I just thought I would make this available to people so that you knew about it. Brandon Whitehead is doing a review paper on this topic, but he's released the data set. So it's available, and there's the link. And that's pretty much all I had to say.
Great, thank you very much, Ruth. Excellent talk, and a lot of great ideas, updates, and resources there. So for the moment, we'll go on and ask that Bryce make his talk, and then we'll come back to open discussion on any of the presentations. So just as quick introduction, Bryce is with the new, or relatively new NSF Arctic Data Center.
Great, thanks, Peter. So yeah, my talk today is on how we're at Data One and at the Arctic Data Center looking to improve the discovery and integration of Arctic research products through semantics. And I wasn't really sure prior to coming here exactly what the group was going to be learning, and so I'm really happy to see Peter and Ruth both talking about some topics that are really near and dear to our heart. So I'm really glad to see those things being discussed. Next slide. So yeah, as Peter alluded, and a bit more background, I suppose, I'm a scientific software engineer at NCES. NCES is the National Center for Ecological Analysis and Synthesis, based out of UC Santa Barbara. And we operate the NSF Arctic Data Center, which is the primary data archive for NSF-funded Arctic research. Next slide. This work is being done as part of Data One. Some may not be familiar with Data One. Data One is a federation of data repositories, currently 37 repositories, of which the NSF Arctic Data Center is one. Data One serves the Earth and environmental data communities with data search, discovery, replication across repositories, and numerous value-added tools like semantic annotation and semantically enabled search that I'm talking about today. Next slide, please. Searching for data via natural language doesn't always go so well. For example, take the English word litter. If you're a mammologist, you might be looking for puppies. If you're an urban planner, you might be looking for the garbage variant. And next slide. If you're an ecologist, you probably meant leaf litter. And so really, using natural language, we often find that we're not able to be as specific as we'd like. Next slide. And on top of that, once data are discovered, and we're looking at the various natural language information we have about those data, such as the title, abstract, or attribute names, how do we know that we can use those types of data sets we found in the same analysis? For example, searching soil carbon alone, you might actually be looking for total soil carbon or the organic or inorganic variance, or perhaps soil carbon flux. And so we find to do these types of things, we really need more specific language. Next slide, please. So our approach at Data One is to annotate data sets with specific terms from well-defined vocabularies. And I guess since those things have been introduced, I'm talking about ontologies. Enhance existing search tools with these annotations. And our general approach is that we're using existing standards for annotation and vocabularies, as in we're not doing something different from the crowd, using web ontology language and other tools like that. Next slide, please. But the annotation doesn't come easy. Semantic annotation works much better when more data sets or all data sets are semantically annotated. So in order to do this, we need to develop vocabularies to annotate with, and we also need tools with which to generate those annotations. Next slide, please. On the vocabulary side, some vocabularies exist and can be used here, such as those that, say, Ruth was talking about. But there are gaps, and so to fill one particular need, we've developed a new vocabulary for ecosystems called the Ecosystems Ontology, or EXO. This was driven by a paper, I believe, by Chapin et al., looking at the kind of a gap in the terminology for carbon cycling. And this specifically targets Arctic research, as carbon cycling is a fundamental area of research in the Arctic. Next slide, please. So to annotate these data sets with these vocabularies, we're going to be doing manual annotation via user interfaces that exist on dataset landing pages, so scientists can make annotations. And then also to fill in annotations where scientists don't manually annotate, we'll be looking at semi-automated annotation algorithms to annotate across datasets. Once the annotations are generated, we'll be providing semantically enabled search across those datasets. Next slide, please. This is a screenshot showing the prototype we have of semantic search. In this case, it doesn't really show it very well in the screenshot, but the person has basically been looking for terms with the word soil. And here we see kind of a tree. And so because we're using ontologies, we actually have kind of that graph or tree type of relationship here, showing that there's a number of terms which are subclasses of one another, and we can go more specific or less specific. In this case, we've kind of hovered over total soil carbon, and we have a specific definition for what total soil carbon is. And the person can then search for data sets that specifically use total soil carbon and potentially less specific terms. Next slide, please. Here we see a dataset landing page. And in this case, we're focused in on a particular data entity in that data set, which has a number of attributes. And in this case, we've zoomed in on the attribute litter, which by itself isn't a very specific term. But we can see that a manual annotation has been provided to say that litter actually refers to leaf litter carbon pool. And below that blue tag, we see that we're also searching for other concepts with which to annotate. And this is a type of tool that would be present to the scientists that is both authoritative on the data set, as well as scientists who maybe are familiar with the field and are looking to fill in annotations on other data sets. Next slide, please. And then on the semi-automated annotation approach, we're using a combination of natural language processing methods and machine learning techniques to suggest likely vocabulary terms from structured metadata. Essentially, kind of a black box approach where metadata comes in, so we're processing things like the title, the abstract, and the attributes, and out come a set of likely semantic terms that relate to that data set. Next slide, please. So the sort of next steps for this, we've been doing lots of prototyping and had a lot of success so far. We'll be deploying the semi-automated annotation algorithms within Data One. We'll be deploying the manual annotation UI to dataset landing pages on Data One and on member repositories such as the NSF Arctic Data Center. And we'll be deploying the semantically enabled search to Data One and the member repositories. And specifically, we'll be looking to apply the semantic annotation process to NSF Arctic Data Center holdings to improve that repository search and interpretation, with a specific focus on some of the carbon cycling measurements, because we have this fairly specific ontology with which to describe those things. Next slide. This work is done, as I said before, as part of Data One. The PIs on that are Mark Schiltauer and Matt Jones from USB NCs, and as well as Deborah McGinnis from RPI, and as always, many, many more collaborators. So please get in touch via email, or I'm happy to field questions after this talk during the question period. Thanks.
Thank you, Bryce. It was a great talk, and it's really great to see some hands-on examples or some tangible examples of the semantics approaches. So thanks as well to Ruth for her great talk. I think this really gave a great overview of the different things that are going on, some of the different possible applications for semantics, but also some of the complexity of trying to build ontologies and semantic and vocabularies, etc., as well as even trying to navigate, what's out there already and how it's being developed, and if there are competing and or similar type ontologies. So thanks for giving us that background. I will say, just before I open up the floor for questions, that I mentioned Oystein Godoy from NetKnow. He was unable to make it today, but wanted to just pass along his interest. He's been doing some work with the Svalbard integrated observing system, some similar applications at looking at the search applications as well as data sharing, and then also with the Global Cryosphere Watch. So he wasn't able to make it today, but is certainly interested in engaging in this broader conversation. So with that, I will open up the floor to any questions that people have from the audience before we go on to the end of our agenda.
Well, I have a question. This is Mark Stiglitz. How ready is that carbon ontology? Is it in production mode in a sense?
I wouldn't say that. As Ruth alluded, the ontology development is really difficult, and we've been kind of ground truthing that and developing that on Data One's holdings at large. And so it's kind of, we're sort of building it as we need to annotate. So I think that's kind of the state of it, is that we identify gaps in the ontology as we look to annotate data sets. And so we'd probably be more in a scenario of rapidly publishing updates to the ontology as we do our work.
Right. So in a sense, it is ready for production. It's just that it's always being updated, essentially.
Very, very true. Yeah. So far, it's been very useful. We've annotated about 1,000 data sets across Data One with some very specific types of measurements, and we've had a lot of luck doing that. And so I think we'll find once we go to the Arctic Data Center or other repositories to annotate their more specific holdings, we'll find gaps. And we'll just need to define terms and define how those terms fit into the ontology and kind of re-release the ontology as we go.
Mm-hmm.
And I'd like to expand upon that comment just a little bit, in that Pierre Luigi has been working with Bryce's group, the NC's group, on ensuring that ENVO and their carbon ontology are in sync. And Pierre Luigi is working with the Suite group and me on ensuring that these other ontologies, and in my case, it's mostly all the cryospheric ontologies for permafrost and glaciers and snow and everything that's basically in the Global Cryosphere Watch suite of glossaries. So as long as we, I think, maintain contact with each other and are trying to work to make sure our ontologies all play nicely, I think that will be a good thing for the entire community.
Mm-hmm.
I have
I
a
would
question.
also.
Oops, sorry. Go
Sorry,
ahead.
go ahead, Sarah.
I was moving on to another topic, so if finish up if necessary.
Well, I'll just say, just sort of following on Mark's comment and question, is that ontologies benefit from real-world application, so they do need to be implemented, to be really tested, and they are pretty much always living and evolving. I think that's a general sort of truism for ontologies. Go ahead, Siri Joda.
So my question was also to Bryce, and it had to do with semi-automated annotations that he discussed, and he said that you're applying natural language processing and machine learning to the metadata. Those are pretty high-powered techniques, and the metadata usually, the free text pretty much amounts to the abstract and maybe some keywords. My question is that almost every data set like we have at NSIDC has a guide document that instructs users on kind of summarizes the ATBD and error characteristics and what data fields are in there and the structure. If you're doing NLP and machine learning, why not point it at those documents? Because they're going to contain a lot more terminology and relationships between things that would be useful in generating those annotations.
Yeah, that's an excellent point. And it's really common for the data sets that we work with, is that we have supporting documentation, which is super useful. And I don't think the group has ruled that out as a mechanism. Our API supports that pretty naturally. And so it wouldn't necessarily be a major shift in the methodology to include more information. We've actually scoped it out pretty narrow so far, so we have room to grow in terms of what information we're sending into those algorithms. But yeah, thanks for the idea. I think that's a great opportunity.
Okay.
Thank you. Do we have any other questions? We have a few minutes for a couple more, I think. Or any comments about what you may be doing in your own work or at your center.
I have a question. So this is Bill Manley with University of Colorado and RMAP and AOV. So this is really great to learn more about, semantic discovery and access, for example, with Data One or across data portals. But in thinking about systems for logistics or science planning, does anyone know of ontologies that enable interoperability for project level, like higher order level, project level information, or at the monitoring site level, metadata for Arctic observing? And I'm thinking here generally about moving from semantics to broad interoperability among portals for discovery and access of kind of science planning level information.
Well, I know of one project, though I can't remember the name of it off the top of my head, that actually at a really high level deals with, well, it's not so much project planning, but project status. It basically has all the information about NSF projects and the people who are working on them, where they're working, and those sorts of details, and allows you to trace connections between projects and programs. And that's a little bit higher level than I think you're thinking of.
That might be the project that Alison Gaylor and I are involved with, the Arctic Research Mapping application. RMAP.
Yeah, yep, that would be the one I'm thinking, I think.
And we haven't, developed or aware of a formal ontology. We have, contributed as best we can with data dictionaries and schemas and other things like that. But going from semantics to interoperability, there is kind of a, a leap there, I think, that needs to be made in terms of interoperability across portals, or even interoperability, or say an ontology for bridging different standards of data set level metadata. You follow me?
So, Bill, this is absolutely a critical topic that you bring up, and I'm here actually. I'm talking from my hotel room in Vienna. I'm at the EGU, and there's several products. There's several projects like in Viri Plus, okay, within the European Union, very much focused on this. Bridging the research infrastructures from different disciplines, and three I can think of as a Viri Plus, and then EPOS, the European Plate Observing something or other system. I can't remember. They've been running for several years now, and I made a presentation, early on at one of their planning meetings. I think they have a complete ontology related to the projects, the measurements, the personnel, tying all those things together. And then on the ocean side, Nexos is called, NextOS. And if you Google that, you'll find web pages. And they also are developing vocabularies to describe, they have a whole, they're all about SWE, right? And so all the instruments are, use Puck, and they're self-describing, but I think that their whole, the domain expands out to linking to, so there's the sensors, there's the platforms, there's the personnel, and they kind of like linking all that together as well. So look on the European side for some models perhaps, or even ontologies to reuse.
So, Bill, this is Peter. Just to add to Ruth and Sergiota's comments, there's also a group of projects and people working under the Research Data Alliance under what's called Mapping the Landscape Interest Group, and they're looking at mapping more projects and actors within different environments, and the Mapping the Arctic Data Ecosystem project is part of that, and so on. So there are some conversations going on there trying to do exactly that, is identify various ontologies that may be useful. The challenge, of course, is that there are a number out there that sort of cross into this space because it's not particularly a polar space. And so it comes down to, can there be some agreement within this community or even broader community on, which ontology or ontologies to adopt? Which I think is where the field is at the moment. As Ruth pointed out with her slide, there's many in the geo space, and it's sort of agreeing on that. So with that, unless there's any other burning questions or comments, I might bring us just to our final agenda item, because we're coming up on the hour. Before I do that, though, I would say that there's a lot of opportunity, just a moment, Ruth, there's a lot of opportunity to comment and ask questions after the fact on the IARPIC collaboration site. So I'd encourage you to do that if you don't get a chance to speak. Ruth?
Yeah, I just wanted to round that out, that actually I was thinking of DIA2 and Research Graph, and I can put the links in the chat for both of those if people are interested in looking at them.
Great, and I'll add some as well from the RDA group that we've been sort of bouncing around, and we can just sort of go from there, I think, and then think about where we might want to put that, which actually leads me into our item 5 on the agenda. As I said, there's been a lot of discussion about this topic over the years in the polar community, and particularly in the Arctic community, as well as some in the Antarctic. So this has come up a number of times in the Arctic Data Committee discussions, and then it's come up here in the IARPIC group as late as the March 30th meeting, or our last meeting here. It came up as a topic for the next year 5-year plan. So I wanted to put out the idea of forming a very loose, not sort of a lot of onerous sort of responsibilities and requirements, but a group from the polar sort of domain that would do things like this meeting, and maybe some documentation, sort of pooling some resources in that, so that we can sort of keep in touch at least about semantics and vocabularies, but with the strong recognition, we don't want to sort of create a silo of polar folks working on all these things by themselves, knowing that there are groups like ESIP and RDA and so on out there. So the idea would certainly to be part of those conversations and part of that, but also maybe just to have something that's a periodic meetings, and also maybe some online resources moving forward. What's been proposed formally within the Arctic Data Committee structure is to have a working group essentially, or a focus group on this. But I'd really like to try and link that at least with IARPIC, but any other group as well, sort of with a polar interest. So I just wanted to get people's general ideas, and if we don't have time here, maybe just put it on the site as to whether or not that would be useful, or whether there's a reason we would not want to go down that road. So we have just maybe a couple minutes to put that out there.
Yeah, Peter, I just wanted to say, this is a great discussion. I am, in about 2 minutes, I'm going to have to go. So I just want to let you know. And yeah, it's really interesting, everything that people have talked about. If we could figure out how to continue it, would be nice.
Okay. Well, thank you for that, Mark. And I think we do have a few people who are willing to put some of their time in just to keep things moving along.
Yeah.
Again, recognizing everybody's busy and they don't need yet another series of onerous meetings, but at least coming up with that sweet spot maybe of staying connected while staying productive in our everyday lives. So.
Peter, this is Sarah, and I see people have put a lot of links here.
Mm-hmm.
I think I can share without too much trouble here. This is the IARPIC Collaborations website, and the teams each have a page here. And so on the Arctic Data team, I'm going to add all these links.
Great.
Over here on the right side. We don't have any here yet, but other pages do. And we're going to add all these links. And I would suggest that people keep this dialogue going. And the best way to do that is to comment on any of the presentations. And so you could comment here under Bryce's. I think this one shows me, but that will switch to Peter. So there are opportunities to comment in the comment boxes right here, and that will keep the dialogue going.
Great, thank you, Sarah. We are at our hour. I can stay on for a few more minutes, but I certainly know that people may need to get going. But if there are any other comments right now, maybe feel free to add them, and if not, just add them to the dialogue as Sarah has indicated.
Well, real quick, Bill Manley again. I'd like to echo your thoughts and support the idea of collaborating with the Arctic Data Committee. I mean, you know, you mentioned not being in a reclusive silo in terms of what's going on outside the Arctic, but also we should pay attention to what's happening elsewhere in the Arctic.
Great, well, thank you, Bill. Any other quick comments before we wrap up? Okay, well, I'll leave it there because we really work hard to keep these on time, and we've been successful so far. I will be following up and through the message thread and other means. And as I said, Oystein Godoy has indicated that he would be happy to take a leadership role in this. If there are others as well who are interested in terms of helping to coordinate the conversation and so on, then please let us know in one way or another. And then we'll try and keep the momentum going over the coming weeks and months. Okay.
So Peter, just to let you know, I'm very happy to collaborate and follow Oystein's lead or help, whatever, either of those.
Great, great. Well, thank you all, and I will leave it at that for now. I really appreciate your participation, and I look forward to our next meeting. This group meets the last Thursday of every month at 1 o'clock Eastern. So Mark Stieglitz and I will be out to you soon with ideas and agenda for that. And I think we're now having a conversation about doing a meeting with other groups in IARPC on governance of the Arctic Observing System. And that will probably be towards the end of June. Thank you all very much.